In only about 10 hours, the Vera Rubin Observatory found more than 2,000 asteroids that had never been seen before. That number alone should make anyone pause. Not because those asteroids are dangerous. The 7 near-Earth asteroids discovered in the first batch pose no threat, but because they had been there all along, quietly traveling through the solar system, hidden in plain sight. Rubin found them almost immediately. The real question is not what Rubin saw. The real question is how much every telescope before Rubin has been missing. This matters because the solar system is far from empty. It is crowded with moving objects, asteroids, comets, fragments of rock, isobodies, and perhaps even visitors from other star systems. Most are harmless. Some are scientifically invaluable. A small number could one day become important for planetary defense. Rubin's greatest strength is its ability to scan enormous areas of the sky rapidly and return repeatedly to detect anything that has moved. That makes it one of humanity's most important tools for discovering objects before they can surprise us. Its first images did not merely reveal new asteroids. They revealed the true scale of what we had been missing. The first truly astonishing discovery made by the Vera Rubin Observatory was not a distant galaxy, a black hole, or an explosion at the edge of the universe. It was something much closer, objects moving quietly within our own solar system. In only about 10 hours of early observations, the observatory detected 2,104 previously unknown asteroids. Not over the course of a decade, not after a year-long international campaign, but in roughly a single night. Among them were 7 near-Earth asteroids. None of those 7 presents any danger to Earth, and that is reassuring. But that is not the remarkable part. The remarkable part is that they were already there, already orbiting the Sun, already reflecting sunlight, already part of the hidden traffic of our solar system. We simply had not noticed them. That is what makes Rubin's first images feel so different. They do not simply show us the universe, they reveal how much of it has been passing unnoticed through our blind spots. For decades, astronomy has been powerful but selective. Telescopes focused on one object, one region of the sky, one survey at a time. But the sky does not wait for us. Asteroids move. Comets fade. Supernovae appear and vanish. Interstellar visitors pass through the solar system and disappear forever. If we are not looking at exactly the right place at exactly the right moment, the universe keeps its secrets. Rubin was designed to change that. It does not observe the sky like a traditional telescope. Instead, it sweeps across vast areas, returns repeatedly, compares images, and searches for motion. A point of light appears in one image, shifts slightly in the next, and moves again in the next observation. That movement tells astronomers they are not looking at a distant star, but at something much closer, an asteroid, a comet, a fragment left over from the formation of the solar system. It may be harmless. It may hold priceless scientific information. Or it may become important enough to monitor carefully in the future. That is why the number matters so much. Discovering more than 2,100 new asteroids in only about 10 hours is not simply an impressive achievement. It is a reminder of the enormous scale of our solar system. If Rubin could find so many objects before its full survey had even begun normal operations, then the solar system is far more crowded than most people imagine. It is not a collection of clean planetary orbits moving peacefully around the Sun. It is a constantly shifting swarm of debris, ancient rocks, icy bodies, and countless fragments left behind from planetary formation. Most are small, and most are harmless, but there are millions of them. Until we can scan the sky quickly enough, widely enough, and often enough, many will remain invisible. This is where Rubin becomes more than just a telescope. It becomes a detection system, a planetary defense instrument, a tracker of cosmic motion, and a reminder that the greatest danger is not always the object we can see. Sometimes the greatest danger is the object we never knew existed. The remarkable thing is that Rubin did not discover those asteroids because they were unusual. It discovered them because it finally had the right kind of eyes. And those eyes are scheduled to scan the sky again and again for the next 10 years. Rubin's greatest advantage is its extraordinary field of view. Most famous telescopes operate like powerful microscopes. They focus on a single target and reveal breathtaking detail. The Hubble Space Telescope can stare at a tiny patch of sky and transform it into an iconic image. The James Webb Space Telescope can peer through cosmic dust to study galaxies from the earliest chapters of the universe. Rubin, however, was built with a completely different purpose. It is not a microscope, it is a surveillance system for the entire sky. At the heart of the observatory is the largest digital camera ever built for astronomy, containing 3.2 billion pixels. This enormous camera can capture vast regions of the sky in a single image while maintaining enough detail to detect faint moving objects. That changes everything because asteroid detection is not simply about image sharpness, it is about coverage. Astronomers must first observe a large section of the sky, then return to it repeatedly, compare the images, and identify whatever has moved. One point of light remains fixed. Another shifts position. That tiny shift becomes the clue that reveals a previously unknown object. As Rubin repeats this process night after night, the night sky stops behaving like a single photograph and begins to resemble a movie, a time-lapse record of the entire solar system in motion. That is why those first asteroid discoveries are so significant. They are not the final result. They are only the opening frames of a much larger story. During the early years of its survey, Rubin is expected to discover millions of previously unknown asteroids. Millions. That means the map of our solar system is about to become dramatically more complete, revealing main belt asteroids, near-Earth objects, Trojan asteroids, distant isobodies, and countless objects too faint, too small, or too fast for previous surveys to detect reliably.